the study time at the end, depending on how things are going and time-wise. Or if we want to as a class, we can keep going through all three. So we'll just kind of see how the first one goes and what you guys are feeling like. So,
Eight, 1, 3, 3, 2, 2, 9.
got about 5 more people need to log in. So if you don't, you play the first one while we're waiting for these. This is ridiculous. Okay, so the first one's only 10 questions, so those of you who are waiting for computers, just kind of follow along until we jump in on the next round. So I got 3 rounds set up. If I can instructions, we're not waiting. So Newton's laws. 9 questions here. So what is the basic unit of measurement for force? One person's not answering, so everybody's got to wait.
Nice.
Only 2 got that wrong. Which law of motion is also called the law of inertia? Meaning an object in motion stays in motion, or an object at rest stays at rest.
I'm just gonna guess the first one. Yes!
Newton's first law is law of inertia, stating that an object at rest will stay at rest and an object in motion will stay in motion unless acted on by another force. So this force equals...
Oh, this is easy. Distance over time. Both.
Mass multiplied by acceleration. The dash means divided by. Which law of motion states for every action there's an equal and opposite reaction?
Okay, it's not the first one. It's the second or third. I'm gonna guess third. Yes!
Really? Third law is equal and opposite reaction. You guys need to know which law is which on the test quiz. I guarantee you will have to know that. So if you are getting those mixed up, that's something you need to study and make sure you've got which one applies to which and what happens in each of the 3 scenarios figured out. Which of the following is not A contact force.
Not a contact force.
Meaning a force that's created by contact of two things.
Pretty sure it's air resistance.
Applied force means you push something. You're actually physically pushing it.
Oh.
You don't have to have direct contact for gravity to affect something. Everything else they have to physically touch in some way.
Okay. That's good. Resistance.
Air resistance will increase with an increase of or in. Think about the book falling versus the paper falling. Or a parachute there versus a guy.
Mass. What?
Air resistance, that is the amount that the air hits. Okay? If you're heavier but the same weight, the air resistance pushing on it's the same. If you've got a big parachute though, it's going to catch more of that air, so it creates a lot more friction of the air as it drops, and that's why a parachute keeps you from falling to your death. Yeah, you guys haven't done as well on this as I was hoping you would. A force that attracts one object to another. It just tells me this room needs to study.
That attracts normal. Applied. Normal? Question mark?
Friction does not attract two things to another. Although I can see how some people thought that because friction, it feels like it sticks as it goes. But you don't have two objects randomly move towards each other because of friction. Okay?
Not good. No.
So gravity is the attraction of any two items with mass. So my little joke is that if gravity means that any items that have mass are attracted to each other, then technically everyone in the room is attracted to everyone else. Technically speaking.
Nice.
Which law of motion gives us a way to calculate force? Ignore the picture, it's not helpful. I pulled this one offline, and the question's good, the picture doesn't. One of the laws is simply stated as force equals. Second law is force equals mass times acceleration. Smaller mass, same force applied, it accelerates more. I don't know why they used the picture they did. I didn't change that. But didn't really have time. How much force does an object with a mass of 5 kilograms that is accelerating at 10 meters per second have? Force equals mass times acceleration. Make sure you get the units right.
Well, I'm just gonna guess.
Four people that said 50 kilograms. Kilograms is a unit of weight. Newtons is the applied force. The other 5, I don't know how to help you. I probably do, but not just looking at your game.
Oh, dude, I got second place.
Okay, so that's the first round.
Crazy.
6, 4, 8, 6.
What?
4, 6. Laser.
Okay, looks like
Rocket blasting off.
A rocket blasting off.
which law would that be? Showing most that the force that makes the rocket go.
I don't really know.
Think about the balloon rocket. What made it go?
Oh, it's right.
Every action has an equal and opposite reaction. Newton's third law. So a fireman turns on a hose and is knocked backwards. Which law is going to be best applied there?
Okay, I'm pretty sure it's the third one. No, stop. Yes.
Again, he's getting pushed backwards. It's equal and opposite reaction.
Wow. There's
Okay.
7 for
It's
every
third law.
answer. That's pretty neat.
It takes more force to throw a bowling ball than a baseball. Which law is that based in?
I think I got that one right.
Yes.
Better. If it's talking about force equals mass times acceleration, so the change in force changes the acceleration, that's Newton's second law. The relationship between the mass and how much it accelerates by a
I'm
force.
too nice with it.
So a soccer ball will not move until you kick it.
First law. Force applied. Equal opposite reaction. Yeah.
Almost everybody got that one. Good, that's better. It takes less force to pull an empty wagon than a wagon with someone in it.
Second law. Yes.
Second law. Once again, you're changing the mass.
Top 5. Let's get it.
A bowling ball hitting pins, then they fly backwards. Focus on the fly backwards.
First. Either first. Yeah.
At first I was like, oh, it's third one.
That question I think I should probably change a little bit. So a bowling ball hitting the pins fly backwards because they're hit, so there's an equal and opposite reaction. But they stay stationary until the force is applied. So it's really, and you've got a mass of the bowling ball, so you could really make a case for all three. So I don't really like that question.
Like the pins don't move while the ball goes down the thing.
Yeah, I don't like that question. You are pushed backwards into your seat when an airplane takes off.
Oh, what? I'm a dingus.
I say 3-2. Yeah, I'd say 3-2. The first time I played this one, I'm not liking this one as much as the other two.
No.
One is also called the law of inertia. An object in motion will stay in motion, or an object at rest will stay at rest.
First one, yeah. Triangle. Illuminati, don't fail me now. Yes. Back in top 5. Second. 21. Yes.
Second law. The air is let out of a balloon and it flies around the room?
Third law.
This one. That was tricky.
Yeah.
Yeah, you can kind of say that for most of them. Which one is it the most relevant to?
I'd have to say one, but I answered three, so.
If you look at the diagram, it has the arrow showing equal and opposite, so it's
I'm
pushing
in
that.
fourth.
Yeah, you could make a case for Newton's first law because it doesn't go anywhere until the forces of life. The important part is not whether you
The
got
foot pushes
you get everything right or
up
wrong on this,
as
if
a
you understand the
person's
three laws.
foot pushes down.
Equal and opposite reaction is the third law. A car accelerates faster than a truck.
I have so many blues. Wow. That's not always crazy.
Assuming they have the same size engine. Here's the
Third
second
place.
law. A magician pulls out the taper claw from under the dishes, but they do not move. The dishes are still standing.
This is tricky. I'm gonna guess first law. Oh,
That's the definitely
second
best
place.
explanation for Newton's first law. It's a really kind of the classic example that you'll get from a first year physics class, like at the early part. Where
It's
they
over
introduce the first
9,000.
Reintroduce it and remind everybody of it. They kind of go over it. That's the most common example of Newton's.
Over 9,000.
You can pull something out from underneath it. They don't go with it because they are at rest. They stay at rest. The force isn't enough to move it. You pull it slow, they go, but real quick, it'll stay. A child pushing on a swing requires less force than pushing an adult on the swing. Second law.
First place. I am number 1A.
A swimmer pushes back on the water as they stroke, and that pushes them forward.
This one, baby.
Just gotta keep it up.
A cannonball shot forward, and the cannon moves back.
Possibly.
Equal and opposite reaction.
Second. Mm. 18, 19, 20, 21. 4 more questions. Pencil and a table will stay there until someone picks it up. First of all.
Oh, that's easy. That's easy.
I am number 1A. 19, 20, 21. I gotta go faster than this one. Pull slow.
I'll be right back. Sorry, guys. I gotta go pee.
Second law.
As quick as I possibly can.
Okay, just 2 more. A train suddenly shows at the train station, and the cars continue moving forward. Equal and opposite reaction. Still in first place. The scientists discovered gravity, developed 3 laws of motion, and had Isaac Newton. In first place.
Hell yeah, brother. Third place, boys.
First.
Were there any questions about the difference between the 3 questions? I know some people are like, okay, I guess I need to study that, right?
I only missed 4 questions and I got first place. Nice.